Hello everyone. Um, Now we'll be starting our first experiment of PSCAD. In this first experiment of PSCAD, uh, there are certain things we'll be learning. Like in the manual, it is mentioned in this experiment we'll be learning creation of a new project and then addition of components from the master library into the project window. Then setting the parameters of the component so that we'll be running the simulation in a nice way. And then we'll be learning about some of namely two important components available in the PSCAD, that is data signal label and output channel, and how a plot can be created from the output channel. And going forward, we'll be doing three activities as an application to these components that we have learned in this video. So coming to PSCAD, the environment looks like this. Now for creation of a new project, you just have to click in this file menu, file option. Then in this, you have to specify a new name. Like I can specify a new project maybe. Then you have to select on the new case and you have to select the location you want your project to be in. Like I can select my D drive and there is another folder here. Yes, lab materials. Yes, I can select this one. Okay, then I can click on create. See, a new project has been created. A new case has been created with a name new project, and in this way. And for adding the components into this project window, go to the master library, and then here, if you just click on this plus, you will be have here. It will be also showing there are various list of components included in the master library. From this master library, like just click on any one of the options. Like let's say I want something from CSMF, so I'll be going here. I'm just copying it, and this is my project window, new project. Then I'll be just pasting it here. Okay. In this way, you have to add your components from the master library to the project window. Then you just have to save this. Also there is also some changes in the workspace also, so to save these changes I want to save this so that it will be getting saved. So also now next we will be learning uh, like uh, we'll be learning the further things like creation of a new plot and the output channel and the data signal label from the experiment only. Now going to your first activity, like if I go to your PDF, the first activity, uh, here it is written that obtain a sine wave having a magnitude of 10, phase shift of 10 degrees and a frequency of 60 hertz. Then you have to multiply the obtained sine wave with a magnitude of 10 and plot the output. Let us first do this. What I have done, I have taken uh, AM, FM or PM function from the master library. I have already mentioned in the manual from where exactly you can get this component. So here you just have to set these parameters, like the input should be in degrees and the frequency input should be in hertz. The carrier function is sine here. So since I want to have a magnitude of 10, so I am giving an input as 10 to the magnitude. I want to have a frequency of 60 hertz and a phase shift of 10 degrees. And then this result will be multiplied with the magnitude of 10 and the output result will be plotted. For plotting, what we have to do, we have to use a data label. Data label is basically available in the components tab here. This is called data label. You just have to click it and bring it here. Just one click. Then you have to just double click it and rename here. Like here I have renamed it as out. So you in this way you can do it here. So I'm just removing this. So this data label can be as it it can act as a reference to be given at uh, various places in this page. So here I am utilizing this data label to plot my output using the output channel. Output channel also you can get from this component tab. Just have a single click here, get the output channel, and here in the output channel you just can use this option, use signal name as title, so that it will be uh, like it will be renamed as the same as the data label, uh, as you have named the data label. I'm just deleting it, I already have that. And for plotting it, you just have to right click this and then go to graphs matrix controls, and then you have to add overlay graph with signal. Then you will be getting a graph frame, you can see over here. So you will be just in a single click, with a single click it will be placed there, and you can see the plot in this graph frame. So I'm just deleting it because I already have that. In this way, you can take the components from the master library and do the experiment accordingly. And the next, like in the same question, there is another thing, like, and obtain the phase information from the output signal and plot it. Like you have to plot the output, and from the output signal you have to obtain the phase information and again plot it. So what I am doing is uh, I've just taken a FFT block. Here I have used a data type, because you can see that FFT actually gives harmonic components other than fundamental also. So here I have set my FFT block such that it will be giving uh, one fundamental and other 6 harmonic components, but I don't want my harmonic, I just want the phase of the fundamental wave. So what I'm using is a data type, so that it will be only taking one input, the first fundamental input, and I'll be plotting this. And that variable I have named it as pH, that is phase. So again, the same in the same manner, the data label is given to the output channel, and the same way I plotted it. So let's run the simulation and see what it is coming. It should be, the phase should be coming as 10 degrees because I have given the input as 10 degrees, and sine wave will be coming. Here we can see that sine wave, it is coming like this. If you I just click on it and press X and Y, it will be like this because I have run the simulation for 2 seconds. So you can also click over here and zoom it like this to see that whether your frequency is 60 hertz and the magnitude will be 100, because the sine wave magnitude is 10 and we are multiplying 10, so the peak will be 100. And here, and we can see that the phase is coming as around 10 degrees, as we have given it as 10 degrees. It is almost 10 because it is giving us 9.9988 something, is approximately 10 degrees only. So this is your first activity of the first activity uh, of the first experiment. Going to the second activity, uh, coming to the PDF. In the second activity, what we are doing is we have to run the simulation for the 2 seconds, and we have to obtain a plot such that it will be showing a value of 10 for the first 1 second and a value of 50 for the next 1 second. Like it will be having a step change from 10 to 50 at 1 second. So let's do that. And that this 1 second is the simulation time only. Okay. So in the next activity, what I'm doing is I've taken a simulation time block. You will in the manual you will be finding the location, from which location of the master library you will be getting these blocks. And then this is a single input label comparator block. Then this is a 2 input selector. What I'm doing is I'm setting my threshold value as 1, because after the threshold crosses, it will give the output as 1, and when the output will be 1 and the control signal will be 1, and if the control signal will be 1, the out signal will be getting its input from A input port, otherwise it will be getting input from B input port. So that for from 0 to 1 second, the output will be 0. In the in the similar manner, the input to the control signal will be 0, and the out data label will be getting signal from B input block, so we'll be getting 10 for first 1 second, and for the next 1 second, this control signal will be 1, and the out data level will be getting input from a input block, that is 50. So running the simulation, yes, for the first 1 second we'll be getting 10, and there will be a step change at 1 second, and for the next 1 second we'll be getting 50. So going to the next activity of the first experiment. So what is given here in the next activity? Here it is written that build the network given below in PSCAD and obtain the plots of voltage, current, active power and reactive power in a single graph frame. And the parameters of the single phase voltage source is given, like voltage should be 20 volts, frequency should be 60 hertz, and we have to obtain the parameters voltage, current and active and reactive powers. And this is the circuit. So going to PSCAD, here what you have to do, you just have to get the components from the master library, and it is already there in the manual where you will be getting these components, and then you have to just connect it using wires. Like if I remove this wire, let's say, you just have to go to the wire mode, then you have to just click here, the single click, then it will just drag, and again one click with the right click button, then it will be this, and press escape button, so that this will be getting connected, these two components will be getting connected. And about the parameters, you just have to go to the signal parameters and set it as 20 volts and 60 hertz. I have not changed the value of impedance, you can try with that. And this register you will be getting from components tab. Here the register is available. This is inductor, this is a resistor. Yes, you just have to single click and bring the resistor. The default value is 1 ohm, you can use this. Okay, and also the multimeter is also available in the component tab. You can go to this, okay, here this is the multimeter. You just have to click here and bring the place it in series, because ammeter has to be in series with the circuit, voltmeter has to be in parallel. So in that way it is already there, and you have to just fix it in between the circuit. Okay, so then you have to double click on the multimeter. Just you have to just click yes to all these measurements, uh, because I require my instantaneous voltage, current, active power flow and reactive power flow. Right now I am not so considering the RMS voltage current. I've just made it as is, like this. And you have to fix the frequency as 60 hertz, because my source frequency is 50 hertz and base MB as 1. Then you have to just name the signal, like instantaneous phase voltage will be V, capital V, instantaneous current will be capital I, active power will be P, and reactive power will be Q. Then these particular signals, you just take the data label uh, and name it as the same name as you have given in that multimeter block, and then connect it with output channel so that we can have a plot. And in this question also, there is one thing mentioned, is that we have to plot the signals in a single graph frame. Okay, what we can do is, you just have to, here there is graph frame, you just have to take this graph frame, there will be no plotting signals here. You just have to click on it, copy it, then click on the graph frame and paste graph. In this way, what you can do is, in a single graph frame you can have 4 different signals. Okay, okay, in this way you can do that. Like this, I have taken all the 4 signals in a single graph frame, just deleting it because I already have that. And then to plot a single graph, after running the simulation I will show. Okay, first I'm running the simulation. Okay, see what I'm doing is, first I am just, now every signal I've made that every signal will not be plotted here, plotted here. uh, then I wish my voltage signal to be I want to see my voltage signal, so you have to just click yes for the view, and then press here and click Y, so that it will be auto scaled. So another thing is that this output channel block, when you will be plotting, automatically plots the signal in kilo voltage or kilo ampere range. If you want your signal to be plotted in ampere or voltage range, then you will be getting the signal in, then you have to just scale like 1000. This is the scale factor. You can use this scale factor, and you can plot the signal in voltage and ampere range. Okay, so here what I'm doing is I'm getting this result. This is the voltage signal. Okay, and now if I want to view my current signal, I have to just check this button. This is my current signal. Okay, then if I want to view my active power, this is my active power. What I want to just do is just click Y, so that it will be auto scaled. It is very low because I have not scaled this output channel blocks. You can scale this and see. Okay, then this is reactive power. It will be zero because we don't have any um, energy storing elements in the circuit. It is only resistors, so reactive power will be zero definitely. So in this way, you can plot in a single graph frame. This is all about our first experiment. It includes 3 activities and the basic introduction to PSCAD. You can refer to the manual. It has been designed uh, so that it will be easy for you to have this experiment done. So that's all. Uh, Thank you.